Good morning, students. This is Dr. Eustace Russell, working as Assistant Professor in the Department of Mechatronics Engineering at C. Muthukumaran Institute of Technology. So far, we are discussing the subject called Kinematics and Dynamics of Machinery, subject code of MR3451, coming under the regulation of 2021 for the fourth semester, especially for second year students. Last class we have seen, we have seen that the basics of force analysis, why the equilibrium is needed for the various forces. We have seen the applied forces, constraint forces, then followed by static equilibrium conditions for the, that is 2 and 4 members. And what are the various equilibrium conditions also we have seen in the previous slides, previous classes. Today we are going to see the upcoming topics that is left out in the force analysis. You can see one by one. That is static force analysis in simple machine members, dynamic force analysis, inertia forces and inertia torque, D elements principle, superposition principle. Now, based on the static force analysis, we are going to see some basic problems on this. Now, let us go on to the problem. A 4-bar chain mechanism ABCD is shown in figure below. Calculate the required value of torque required T and all the constraint forces on the links for the static equilibrium of the mechanism if F equal to is given as 2000 Newton, the directions shown in the sketch. The dimensions of the linkages are as follows, and the various links are also given here. That is dimension of the links, that is AB equal to 200 millimeters, BC equal to 370 millimeters, CD equal to 250 millimeters, AD equal to 215 millimeters, and CE equal to 100 millimeters. So every time the students must be familiar in taking the given data, that is must. Here we can see that the force that is given, clearly given as force is equal to 2000 Newton, it is given in the problem. There is no need of any conversion of any unit. For drawing the diagram only we have to change on to the scale. Initially we have to write the data what is given in the problem, that is AB is given as 200 millimeters, BC equal to 370 millimeters, CD equal to 250 millimeters, AD equal to 215 millimeters, and CE equal to 100 millimeters. We can see the solution one by one. First of all, draw the given 4-bar mechanism with the given force F equal to, that is 2000 Newton, to some suitable scale, that is 1 centimeter equal to 100 mm as shown in figure. So based on the sketch we have to draw the sketch required to our scale, that is 1 centimeter equal to 100 mm based on the ratio. Now draw the free body diagrams for the links, that is 4, 3 and 2 with all applied forces as shown in figure respectively. We will see the figure one by one in the next slide. Here the step number 3, equilibrium of link 4. Link 4 is acted upon by 3 forces F, that is completely known, F34, that is direction only known and parallel to link BC, and F of 1,4 completely unknown. So only the two things are known, link 4 and F34, the F14 is unknown. So draw the free body diagram of link 4 as shown in figure. Extend the lines of action of F, the F34, so as to obtain the intersection point G, known as point of concurrency as shown in figure. Now join the OD to obtain the line of action of F14. To find F14 and F34, use F and line of actions of F14 and F34. Draw the force polygon. Already we have seen in the previous class of this slide how to draw the polygon. You have seen. The two unknown means we have to draw the lines. Closing polygon will be the unknown one. The same thing we have to follow here also. So draw the force polygon to some suitable scale. Here it is given as 1 centimeter equal to 1000 Newton. For our simplicity, we are making the scale like that. So we know that for equilibrium, the force polygon must close. By measuring the closing side of the force polygon to the chosen scale, we get F14 equal to 1180 Newton, F34 equal to 950 Newton. Equilibrium of link 3. Link 3 is a two force member, that is a F23 and F43 as shown in figure. Therefore, by the measurement we can write like this: F23 equal to minus F232. Why it is minus? Magnitude is same, but direction is opposite. Also, it is equal to F34, which is also equal to minus of F43 equal to 950 Newton. So in the next slide, we will see the how we can obtain these drawings of polygon. We will see in the next slide. So here it is having a glimpse of the force polygon, what we have completed so far here. So in this, the first sketch, the left hand side topmost, already it is given in the question. Free body diagram of the link 4 we have drawn here by making a line, the force that is acting 2000 Newton, then normal to that also the same magnitude, again opposite acting to that point we have mentioned over here, and at the point we have having F3 4, because the 3 and 4 are joining in one common point, therefore it is F3 4. The same thing we are drawing the C, we can see here the name called alphabet C. We are going to draw again for the link 4. We can see here point D is there now, point C. The line of action will be F34, F14, and the line of action will be F, meeting at one point, that is G. Then the force polygon we have drawn here in the alphabet D. Then free body diagram of link 3 is mentioned in the right hand side of the slide. BC link is there, therefore link number 3 we have F23 and F43. We have the joining of these two links as a common point. So therefore equilibrium of link 2 is acted upon by two forces, F12 and F32, and the torque T as shown in figure. Link 2 is in equilibrium only when the force F12 equal to F32, because these both forces F32 and F12 are being parallel and opposite to each other. Therefore F12 equal to minus of F32 equal to 950 Newton. We can see here from the free body diagram of link 2, torque will be applied. Torque, everybody knows that the force into the perpendicular distance. Therefore F32 having a the distance of h. Measurement we can get like this: 200 millimeters according to our scale change to the meter. According to the unit conversion, torque will be Newton meter. Therefore 0.2. Final answer is 190 Newton meter in clockwise direction. The next problem, the same thing. We have a single slider mechanism motion. The slider crank mechanism is shown. The value of force applied on slider 4 is 3000 Newton. Determine the forces acting on various links, and also calculate that the driving torque linkages dimension is given. This problem is also similar to the previous problem, the same dimension like that. Here also it is given AB equal to 100 millimeters, BC equal to 300 millimeters, and BAC equal to angle is given as 60. For that we wrote the given data, then followed by the same steps. What is the first step you have to do always? We have to fix the scale, suitable scale. What we have fixed in the previous problem, the same thing we have to do here also. 1 centimeter equal to 100 mm. Then draw the free body diagrams for the links 2, 3 and 4 with all applied forces. Then what are the unknown, what is completely known and unknown, we have to analyze that. We have to make a analysis of the various links, which one is known and which one is unknown. The same thing, the given figure is drawn over here with some suitable scale. Then using the known lines of action of all three forces, draw the polygon to some suitable scale. 1 centimeter equal to 1000 Newton as shown in the sketch. So here we can see the alphabet B, C, D and E, the various free body diagrams as we discussed in the previous problem. So A and B having a link of the force, that is joining F12 and F32, having a twisting, having an angular acceleration over there, that is mentioned as T, as a figure C having a BC, having a link of F23 and F43. Then joining with one point, fourth point, we can see that all the forces are joining at one common point. Then we are drawing with a force polygon of a slider. So based on that, we are getting a values, final answer as F14 equal to 9400 Newton, F34 equal to 3240 Newton. So now the equilibrium of the link 3. Link 3 is a two force member, F23 and F43 are shown in figure. Therefore, F34 equal to, already we know that magnitude is same but opposite direction. Therefore, we have put in minus of F32 equal to 3240 Newton. Equilibrium of link 2, that is link 2 is acted upon by two forces. Already we have seen mentioned or wrote over in the top, F12 and F32. Torque T as shown in figure. Link is in equilibrium only when force F12 equal to F32. So we can see it is in minus. F12 equal to F minus of F32 equal to 3240 Newton. From figure, already we know that the torque will be force into distance. Therefore, F32 and F12 both are similar. Now using the measurement with a suitable scale, based on the scale what you have fixed over in the previous diagram, h is equal to 100 mm, we will get, change it to the meter. Therefore, 0.1 meter. Final answer is 324 Newton meter, clockwise direction. So this is a reference which I used for preparing this content. Kindly go through this content. So thank you students, thank you for your kind attention. So in upcoming slide will be the last slide. So it should be a final slide for this unit 4. Kindly go through it. Kindly subscribe the channel. Kindly share this video to your friends. So we will see in the upcoming video. Thank you all.